Yesterday we started with this probability density function. So we know that near the we can say mean value, there will be more chances of likelihood of that particular reading. Okay, so at middle point there will be more readings, and as we go away from that, there will be less chances of the reading. So we calculate Z score. So I already sent the table for Z score, positive Z score and negative Z score. Okay. So here in this diagram, it is shown from the midpoint, the shaded area. Shaded area is shown from the midpoint, but for the Z function, we actually calculate from the left. Okay, here shading is done here, but actually we calculate from the this side. Okay, so whatever is the Z value, suppose Z value is here, something minus. So we'll calculate the what is called as area, which is from the left. Okay, so we'll, all this we'll see. You just see the table. I sent you the yesterday table. Okay, I think I will also open that table. Table is open. Okay, I have that. I will just share that.
So can we open the table side by side?
Yeah, I will open that.
Yeah, thank you.
Now we can see here this normal distribution curve and the area on this curve. Okay, so area will just indicate the percentage probability. Okay, so if you see the Z here, when we mark the Z, okay, so this is the midline. Okay, when it is negative, so we measure like this. Okay, so here Z will be -1, Z will be here -3 like this, -2, then here -3. Okay, so whenever I mention some Z, suppose I mention this Z, then I find the area. So area is what? That is probability. It gives in the percentage. So that area, if you multiply by the percentage, then it gives the probability of occurring that. Okay, suppose Z is, you just take the one example. Suppose our Z is 3, and at 3, what is the area? At 3, suppose you go here 3. Okay, from here Z is suppose 3. So how much is the area now? That area will be 0.0013. You multiply by 100. So it is the probability is what? 0.13%. It is very less probability. Okay. So you go to the -1. You go to the, just go to the -1. Z is equals to -1. Now when we say -1, it is more near. Okay. When I say, now if I divide this dome, it will be clear that on the left hand side it is 50% and on the right hand side 50%. Suppose I make it Z is 0. If I make Z is 0, means it should give the how much area? How much probability it should give? 50%.
50%.
Yeah, so we'll just go to Z is equals to 0. We'll see the value. What is the value? Z is 0. How much it is showing now? Z is equals to 0. It is 0.5. So there are two tables for Z. One table is minus, you can see here. One table is minus. Okay, and plot minuses up to Z is equals to 0. Okay, Z is equals to 0, it is minus. Now we'll go down. So this is the first table, then this is the second table. Same thing here. Okay, same thing here. We measure, even though we are measuring the Z from here, please understand here. Like here, suppose Z is 1 here. Okay, but we calculate the area from the left to that point. what we calculate? We calculate the area, shaded area from the left to that point. So Z is equals to 1. So it is obvious that this half area is what? 0.5 means 50%. Now this much will be added. So if you go to the, let us suppose go to the 1, Z equals to 1. Go to the Z equals to 1, you can see here. I'll just clear first.
0.8413.
Yeah. So it is about
84%.
0.8413 means 84.13%. Okay. And we just go to the near to the 0 means what? 50%. 0.50. Okay. So we measure this area. This table is giving what? Area in the curve. What it is giving? Area under curve means it is giving the percentage of probability. It is giving what? Percentage of probability. Okay. This curve is giving what? Percentage of probability. So using this curve, we can solve some problem. Okay. So once you understand that, you can solve the problem. Okay. So I will again go to the PPT. Okay. So in this curve, what we are, the shading area is shown from this midpoint. So how will find? You just find whatever chart I have given, from that you find total area. You find total area minus how much was this area? 50%. So if you 0.5 if you deduce, you will get this area. Okay. So this is a manipulation you have to do based on the type of the problem. So mostly you have to use the table. Okay. Mostly we need to use the table. So I will just clear this.
So one question here. This standard deviation you are not referring to when you are saying in the formula Z is equal to. So I'm just wanting clarity in that.
Yeah, yes, that we will see in the problem solving. We have to take this sigma as based on number of readings. Suppose it is less than 20, then we have to take the n minus 1. Okay, in the sigma formula. If it is more than 20, then we have to use n
plus 1. Okay.
Only n. Okay. If it is less than that, then we have to use n minus 1. Okay. That we'll see in the problem solving. Okay.
Thank you.
Now this is that I have also calculated with the table. Whatever they have given here, na, I have calculated with the help of table. Okay, so I will not repeat that. So this is a table given by that particular book. So how they are taking the area here from 0 to Z. Okay, 0 to Z they are taking. One is what? Please understand, you have to refer that. Okay, here Z is 1. So how much it is giving? 34.13, because they have taken area from the 0. Okay, if they take area from the left, then you have to add 50%. Okay, okay, we need to add 50%. If you take from the left, then we have to add the 50%. Okay, so we will use our table where we take from the left. Okay, we take from the left. Okay, we take from the left. Now, as I mentioned yesterday, that we'll take some problem based on the Z score, so that you will get feeling of that. Okay, so I'll just go that. You can see here, Z score is what? Z score will help you understand where particular observation will lie in the probability. Okay, what is the probability of particular thing? Assuming that it is the normal distribution curve. Assuming that it is what? Normal distribution curve. Okay. So we will take the example that about particular GRE score of the student. There is one student having the GRE score of 1000 and mean of GRE score is 1025. Standard deviation is 200. Okay. So first step will be what? We have to find the Z score. Okay. Once we find the Z score, then we can go to the table, find the area. From the area, we can find the percentage of probability. So then what is asked in the problem? How many percent of student having score below and above him? So we have to find number of student having the score below him,
below 1000,
and above him. Okay. We have to find in the percentage that we have to see from the Z score table. So what is the first step is to calculate Z, value of Z. And then we go to the table. It may be plus Z or minus Z. Okay. So accordingly, we have to see the table. This table I have already given you. Okay. Then once we find the value from the table, it will be in the fraction. You need to multiply by what? 100. So that you will get in the percentage. Okay. Now you have to write whatever is given in the example. So we know the formula for the Z. Anyone tell me the formula for the Z?
X minus XM upon standard deviation.
Yeah. X minus XM divided by sigma. Okay. So you write X. So you just put the value of X. X is the particular marks or anything, and mean is given 1000 minus XM 1025. Please understand now. Here the XM is bigger than the value, so the Z will come negative, means your answer will be less than 50%. Please understand. Okay.
Got it.
Answer will be less than 50%. Now calculate the value from using the calculator. What is the value of Z now?
Minus 0.125.
Minus 0.125.
Minus, yes.
It is minus.
Yes,
okay. So you go to the table first. Now you have to see the first table, which is in negative. You find the area. Yeah. So you have to see 0.1. And vertical, we have to see the 3. So how much it will convert it now? Minus 1. Now see if the next number is 5 or more than 5, you have to increase this number by 1. So it will be 0.13. So you see in the 0.1 column, and in vertical column, we have to see the 0.3. Clear? Horizontal column, we have to see minus 0.1, and vertical column, we have to see 0.3. So that is the value of area. So how much value of area you are getting from the table?
0.3.
0.3. So now you multiply by 100. You multiply by 100 means 30%. There is probability of 30%. So he is in the 30% students. Okay. Means less than or equal to 1000 score, how many student is having? 30%. And more than 30%. That is having the 70%. Okay. Let us see. I have calculated. So it is not 30. Minus 0.1. No, you will see minus 0.1. Okay. You see minus 0.1, and then you see here, I think it is 0.2.
It's 0.4483, sir.
Yeah, it is. No, it is in between that. Okay, our value is how much? 1.25 means it will be in
0.03.
the 1. Yes, 1.2 and 1.3. It is in between that. Okay, that's why I have taken this middle of that approximately. So it is 0.45. Please don't make mistake. You have to solve this problem in the exam. So area is how much? Now it is in between this. So it is coming around 0.45. Okay. 0.45
The
now.
vertical, excuse me, sir.
Yeah, vertical
Vertical
is.
column values are 0.02 and 0.03, right?
It is in between 0.2 and 0.3. Okay. So this value is near to what? We can say 0.02 and 0.03. It is in between that, na? That's why I'm taking between these two approximate. Okay. So you multiply this 0.45. I will multiply by 100. So how many percent of the students are there which are having the score 1000 and below 1000? It is 45%. So he is in the 45% student. And the remaining students are 100 minus 45, it is 55%. So remaining students are 55%, and he is in the 45% student. Okay, so this is probability we can find from this. We can
Excuse
say
me, sir.
yes.
Sir, shall we use the same table for negative also?
No, there are two tables.
Because
One is
the
for there is positive table and there is negative table. Okay, whatever value is coming, here the value was negative. That's why we have to use the first table. There are two tables. One is for negative, one is for positive.
Left hand side and right hand
sir,
side.
Left hand side, yeah.
area under the curve is for right hand side and left hand side is same,
No,
right?
here for this table, it's the area is always taken
Left
from the
hand
left. Diagram is shown. Okay, I will just go to the table. I will just go to the table. I will just go to the table. You can see the diagram here. Okay. From that chart only, this chart we have to only use. So it is here the area is taken from left. Okay, left to that Z value, and Z is calculated positive from here, middle line. Okay. Now we'll go to the. This is a second table, which is the positive. Here Z is what? Positive. We go to the first table. Here Z is what? Negative. Okay.
negative.
So based on whatever value it is coming, Z value may come positive or it may come negative. When it is coming negative, you are clear that your answer will be less than 50%. If it is coming positive, means your answer should come more than 50%.
50%.
Okay. So I will again go to the PPT. We'll take one more problem. We'll take one more problem now. Now we are taking the problem where the student is appearing for 2 exams and we want to compare which exam he has performed better. Okay. Okay. So 2 exams the student has taken, 2 tests. Now his marks and even the mean and standard deviation will be different in different exams. So we have to compare whether his performance was good in first test or good in the second test. Okay, so I will just read the problem. A student undergoes 2 tests. In first test, he gets 78 marks, and second test, he gets the 80 marks. Okay. The mean and standard deviation of first test was 68%, And 68% was a mean for that.
68 marks, sir. 68 marks.
Yeah, it is a mean. Yeah, 68 was a mean for first test, and standard deviation was 15. Okay. Now we'll go to the second test. In second test, the mean was 66 and standard deviation was 12.
12.
Now we have to identify whether his performance was better in second test or first test. So we have to tell based on what area? Area of the what is called as standard curve. Okay. So if it is a more area, means better performance, means more area means what? He is in more percentage of student. If area is this means what? He is in less percentage of the student. If he is in more number of student means what? His performance is good. If he is in less number of student means what? His performance is not good. Okay. So I will just clear this. We'll go. We'll solve one by one. We'll solve for case 1. Case 1, what was his X marks he obtained were 78.
28.
Then mean was 68. You please check. I may be wrong. Huh? You check. You calculate yourself. And the standard deviation sigma was 15 marks. Now from this you need to calculate Z. Calculate the Z.
66.6%.
So it is coming. All please calculate. All calculate. Otherwise, what will happen in exam? 66.8. Yes, is it correct? So we know the in table. It is correct. 66.8.
Yes.
Sir, it is 0.666667. So it should be
That is the same.
0.67.
Yeah. Just I
That
will
is equal to
tell how to
0.66.
how to change. Now we only need after decimal place, we only need the 2 places. So now I want to remove this. Now it is more 5 or more than 5. So it becomes what?
0.668.
It is 0.667. It is 6 now here. Yeah. So again
Okay,
I want to eliminate this. Okay. So it is more than what? 5. So
0.67.
So it will again become 0.67. So our answer is what? Z is 0.67. Because we need only 2 digits. Okay. We need only 2 digits. 2 digits. Okay. Now
So
see the table. Now the value is positive. Please understand. We have to see whether value is positive or negative.
Yeah, it is
When
positive.
value is positive, you go to the second table. Okay. So when value is positive, it is clear that it is more than 50% chances.
Sir,
okay.
correct.
More than 50% chances. So you have to your answer should not be less than 50%. Okay. Now you go to the table. See now 0.6
and 0.07.
Okay. And vertical column you see 0.07. So you got the answer 0.7486.
That is 74.86%.
Yeah. So you need to multiply this 7486% by 100. So you get the percentage 74.86%. So percentage of student having the marks equal or below to him is how many percentage? 74.86%. Okay. So he is in the 74.86%, means almost 75% student. Means he is good. Okay.
Good, yeah.
But we have to compare what? Test 1 and test 2. So we have to again calculate for test 2.
Test 2.
Okay. Please, all of you, please check the table whether you are able to locate the value. All of you, please locate the value in the table. I have already shown you here. Okay. So such problem will be there in the exam. Okay. Exam. Okay. Or also for assignment. Okay. Now we will go for second test and see whether the percentage of the student in which his appearing is more or less. Okay. I'll go to the test number 2. in the test number 2, what is the value of X? So he
80.
obtained the marks 80
Yes.
and class average is 66%. Standard deviation is 12. Now you calculate the Z. See whether Z is positive or negative. First thing.
Positive.
It is coming positive. How much it is coming?
1.66666.
1 point
One,
1.16.
16. Okay.
Yeah.
1.1666.
1.66. Okay. So you need to convert now. Convert this 6. So what will happen now? This is 1.17. So it is coming. Answer is correct. Now you see in the table now whether it is positive or negative. You have to first remember. Otherwise, you will go to the wrong table, and your answer will be wrong. So it is coming positive. So you need to go to the second table. First table is for negative value. Second table is for positive value. So now you go to the 1.1. So after decimal place, you have to take the two values. Okay. So now it is 1.1 first. You have to look at what? 1.1 and then last digit. So 1.1 is here. 1.1 is here. Then you go for, it is what? 0.07. 0.07 is here. So your value is 0.8790. So you write down area is what? 0.8790. So how many students are there having the score equal to him or below him? It is 87.9%. Now, this time his percentage is better. Okay. So how much is the difference of marks? Earlier, it was I think 78. Now it is only 80. Okay.
87.
Okay. Earlier was what? 78. His marks.
74.86.
74.86.
75.
And I am just asking the marks. Earlier he got 78. Okay. Marks.
Marks is 78. Yes.
And he got
Yes,
now
yes.
80 marks. Okay.
80.
So earlier his percentage he was in the 75% student. Now he's in 87%. Okay. So almost how much rise is there? Almost I think it is 13%.
12.
Okay. Just by
30%.
increasing the 2 marks, he's now in more percentage. But why this happened? Because all the students are not good in all the subjects. Okay. So maybe in earlier subject his performance is not good, but this subject his performance is good. Got this? So we need to compare. We need to compare with the number of students he is in that particular group. Okay. So his performance is good in the second exam. His performance was not good as compared to the in first test. His performance was not good as compared to the test 2. Okay. This way we have to identify. Okay. Now there is a simple subject and there is tough subject. How will you compare the performance? Okay. So this way we can compare the performance of the student. Okay. Got it?
Yeah. Yeah.
Now what happens, like many times we compare when we draw the standard distribution curve, but we compare sometime in the range, like suppose plus minus Z is means Z is changing from -1 to +1. Okay. We want to find out the area, but in what way? Around this Z is equals to 0. We have to find the area of this around Z is equals to 0. Means Z is ranging from -1 to Z is equals to +1. So what percentage of area, what percentage of probability will lie between minus Z is equals to -1 to Z is equals to +1? What is the probability? Okay. So I will find that for Z is equals to -1, you go to the table, see what is the value. Check in your table. For z is equals to -1, what is the area value? Check in your table. Let's check in your table. For z is equals to -1, what is the value of area? Yes. Let's check in your table. For that value, you write down point. We will get from the table how much you are getting. Similarly, you find for z is equals to 1, what is the value of area? Then you find the difference between them so that you will get the area around this z is equals to 0. So suppose the area is this much. What is the probability that reading will lie in that? So if you subtract, are you getting the same value?
Yes, sir.
Yeah. So if you find the difference between this and this, it is coming to be 0.6826. Now you multiply this 0.6826 by 100. So how much confidence level? What are the chances that reading will lie in that shaded area is 68.26%. So how much reading will not lie? 31.7% is our chances that reading will not lie in that area. Now we will take larger Z now. Take Z equals to -2. You write down the value from the table. What is the value for Z equals to -2? Can anyone tell me?
.0228.
Yeah, is correct. Okay. Now you
Yes.
find for Z equals to 2, what is the value of area?
0.9772.
Yeah. And now we got these two values. Now you take the difference, higher value minus lower value. You will get the difference. Find the difference. Find the difference. Is it correct? 0.9544. Yeah. Now you multiply by 100. This is the chances that reading will lie in the 95.26% are chances that reading will lie in that particular zone. Okay. What is chances? 95.26% that reading will lie in that particular zone. So what is the percentage of percentage that it will not lie in that area? It is a 4.6% chances. Okay.
Sir, the difference was 95.44, na? So it is
Yeah.
95.26.
Maybe, yeah. Maybe 4 here.
Okay.
Same value. Okay.
Okay. Okay.
Now you go to the greater value of Z. So if you go to greater value, minus Z is equals to -3, write down the value of area and go for Z equals to 3, write down the value of area. Is it correct? Please check because I have done, I may make mistake. Okay. I have not taken from the book, so I may make mistake. Okay. So whether it's correct, then you take the difference. It is 0.9974. Means there are chances that if you take Z equals to -3 to Z equals to 3, there are almost chances that 99.74% reading will lie in that your area. Okay, shaded area.
So confidence level is high.
Yeah. Confidence is more. Yeah, confidence level is high. So only 2.6% are chances that reading will be outside there. So it is very less error. Okay. In this way, we have to calculate. Okay, I may give any value of Z. You have to find what is the confidence level. You have to find this percentage. Okay, in the assignment as well as in exam. Okay. Now we'll move further. Before that, I will clear this. Okay. Is it clear? Now we will see one more topic, that is Chauvet's criteria. So for what we use this Chauvet's criteria is to reject doubtful readings. What happens when we take the reading? There are many factors which affect the taking the reading, like there may be error in the instrument, the error in observing the reading. Okay, sometimes suppose the reading is 1.35, but we write 1.25. Okay, so the human error can be there. So we need to reject. We need to reject the few readings. Okay, if they are far away from, we can say mean, but we cannot just reject the reading, but we have to take the decision based on the statistics. So the criteria was given by Chauvet. So he given the one table. So what we need to do is we need to calculate first mean. Then you calculate deviation. We know deviation. Deviation is what? Difference of given value. How much the given value is away from the mean. That is the difference. So it is x minus x mean. Then you calculate standard deviation. But here please pay attention. What are the number of readings? If it is less than 20, then you have to take the sample standard deviation. Otherwise, you need to take the population standard deviation. So if it is population, then we have to divide 1 by n. If it is sample standard deviation, then we have to divide by n minus 1. Okay. So I think it will end now. We'll again meet after 10 minutes. Okay. Thank you.